So 5.1 deals with perpendicular and angle bisectors. What does it mean to be perpendicular?
To intersect.
Intersect at a right angle. So these two lines intersect at a right angle. And what does it mean to be an angle bisector? To cut the angle in half into two congruent angles. When a point is the same distance from two or more objects, the point is said to be equidistant from the objects. So equidistant means that it's the same distance. A segment, ray, line, or plane that is perpendicular at a segment's midpoint is the perpendicular bisector. So here we have line CP that is the perpendicular bisector of AB because it cuts it perpendicularly, so it's perpendicular here, and it cuts it into two equal parts. So we see that these tick marks mean that AP is congruent to PB. So in order to be a perpendicular bisector, we need it to be two things: perpendicular, and two, to cut in half. So the perpendicular bisector theorem states, in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So here we have point C that lies on the perpendicular bisector CP. So we're looking at point C. Point C, since it's on the perpendicular bisector, it is equidistant from point A, and from point B. So it's equidistant from the endpoints of the segment that it's cutting in half. If I extended the line CP up and I made another point on it called D, D is also going to be equidistant from A and from B. So this will be equidistant to this. It'll be a different distance than AC, but it's still equidistant. So the two yellow lines are going to be the same, and the two blue lines are the same. So any point on this perpendicular bisector is equidistant to the endpoints. That's the perpendicular bisector theorem. The converse of the perpendicular bisector theorem is the same thing but flipped. So if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So here we have D is equidistant to the endpoints, so D is going to fall on the perpendicular bisector, which is CP. So D is on the line CP. We can skip the next slide. You don't need to know this. So example 1, find the measure of MN. So NP is our perpendicular bisector because it follows our two rules that we have. So 1, it's perpendicular, it cuts at 90 degrees. N2. Since MP is equal to PL, it cuts it in half. So NP is our perpendicular bisector. So since we know that NP is our perpendicular bisector, it's equidistant. N is equidistant from the endpoints, M and L. So if NL is 2.6, then what is MN?
2.6.
Perfect.
We're gonna have to do proofs.
Yes. So BC is the same thing but flipped. So we know that AB is congruent to AC. So since point A is equidistant from the endpoints B and C, we know that AD is the perpendicular bisector. So it's perpendicular. We see that by the little box that it gives us. And then we also know that it's cutting the segment BC in half. So if DC is 12, what is BD? 12. So BD is 12. And DC is 12. So then what's BC? The whole segment.
Oh, 24.
24. So find the measure of TU. Here we know that WU is the perpendicular bisector. Because why? What are the two rules that we need to know in order to be a perpendicular bisector? So it cuts it in half. And we know that's true because we see the tick mark here and the tick mark there. So we know that that segment at the bottom, TV, is being cut in half. And what's the other rule we need to know in order to be a perpendicular bisector? That it forms a 90-degree angle. So it bisects at 90 degrees. So since WU is our perpendicular bisector, what do we know about point U to the endpoints, T and V? What do we know about point U from
Equidistant.
T and to V? Right, it's equidistant. So they're the same distance. So since 3x plus 9 is the same distance as 7x minus 17, how do we find x here? What equation do we need to set up? Right, 3x plus 9 is equal to 7x minus 17. So now we just solve for x.
That isn't. Wait, I'm thinking, but like, I was doing the math and like, would it be a decimal? No. Yes.
What's 26 divided by 4?
6.
What's 6 times 4?
I
I mean, what?
Yeah.
Exactly.
So x is 6.5. Is that all we need to do? Is that our answer?
No.
We need to plug it back in. What do we plug it back into?
TU.
To TU. So we plug it into 3x plus 9. So we have 3 times 6.5 plus 9, which is equal to?
Math. 19.5 plus 9 equals. Wait. Yeah. Right.
28.5.
See, don't look at me like I'm stupid, Julian. Well, I said plus 19. I mean, no. Stop.
Okay, remember that the distance between a point and a line is the length of the perpendicular segment from the point to the line. So if we have a point and a line, the distance from this point to the line is going to be the perpendicular line. So remember, this is the shortest distance. The perpendicular one is the shortest distance from the point to the line. So if we're talking about from point A to line BC, it's going to be a perpendicular segment. That's the distance. Okay, next we have the angle bisector theorem. It states that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if we know that point C is on the bisector, then it is equidistant from the sides of the angle. So it's going to be equidistant from A and from B. So we can say that AC is congruent to BC. The converse of the angle bisector theorem states if a point is in the interior of an angle, if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So if this point C is equidistant, which here we see that it's the same distance from A to B, then C is going to be on the angle bisector. So what does it mean to be bisector? Cut in half. So PC, this ray here, is going to cut APB in half. So this angle here is going to be congruent to this angle. So angle APC is congruent to angle BPC. And these are angle bisector theorems. We don't need to know this little sentence on the bottom. So let's look at example 3. Find the measure of BC. So if C is on the bisector, and we know it's on the bisector because it's cutting this angle here in half, then BC is going to be equidistant as CD. So what is BC? 7.2. So now we're given that H is equidistant to the sides of the angle G and E. So HG is congruent to HE. We can tell by these tick marks here. So we know that H is on the angle bisector. So this angle here is going to be congruent to this angle here. EFH is congruent to HFG. If EFG, the whole angle, is 50, then what is just EFG, or EFH? 25. So angle EFH is equal to 25 degrees. Perfect. So last example, find the measure of angle MKL. So we're trying to find this angle here, MKL. Since M is the same distance to J as it is to L, we know that M is on the angle bisector. So we know that JKM is going to be congruent to MKL. So if we know that these two angles are congruent, what do we do with 3a plus 20 and 2a plus 26? Set them equal. So we have 3a plus 20 is equal to 2a plus 26. So now we just solve for a. What do we get for a? 6. So now we take a and plug it into what?
2A.
Angle MKL. So 2a plus 26. So 2 times 6 plus 26. 38 degrees. Perfect. So that's 5.1.